Okay, in this video we do some calculations on motion before we move to momentum. Okay, our first question is, a train has an initial velocity of 44 meters per second and an acceleration of minus 4 meters per second square. Its velocity after 10 seconds is. Now at first, if you want to solve any question, identify the parameters. The initial velocity, which is u, was given to be 44. Then the acceleration was minus 4. This acceleration is talking about, this is deceleration. Then the time was 10. And they say we should look for the final velocity, which is v. Now this is very easy. Which is v? This is very easy. We are going to make use of the first equation. We are going to make use of the first equation. So we are looking for v. U is 44 plus a is minus 4. So bracket open, minus 4, bracket close. The time is 10. So minus 4 times 10 will give you minus 40. Minus plus times minus give you minus. So v equals to, here will be 44. 44 minus 40 will be 4. So the answer is 4 meters per second. This question is very easy. Okay, now move to question 2. Question 2. A car moves with an initial velocity. A car moves with an initial velocity of, a car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 in 10 seconds. So time is 10. What is the acceleration? So we are still going to make use of the first equation of motion. We are looking for acceleration, so we make acceleration stand alone. If this v come to the other, this u come to the other side, will be v minus u equals to 80. To make acceleration stand alone, divide both sides by time. So to be a equals to v minus u over t, which is equals to our v is 45, then 45, u is 25, then all over 10. If you do this one, to give us 20 over 10 give you 2. So 2 meters per second square. That is the answer. Okay, so let's move deeper to some tricky question. Okay, question 3. Okay, we move to question 3. Question 3. A car moving with a speed of 90 kilometers per hour. So the car was moving with 90 kilometers per hour, was brought uniformly to rest by the application of the brake in 10 seconds. That is, time is 10 seconds. How far did the car travel after the brakes were applied? So we are looking for distance. Now, in order to solve this question, we need to go through the 3 equations of motion. Now, if you look at the first one, there was no displacement, there was no distance, so there was no s in this one. Then if you look at the last one, the last equation, there is no time, so we cannot make use of this last equation. Then let's try the second one. The second one contain distance, contain let me say speed, it contain time, and it also contain acceleration. But in the question we were given, they didn't give us acceleration, so we cannot make use of this second equation like that. But there's something we can do. Now take note that whenever in some particular questions on motion, we can combine 2 formula. We can use 2 of the 3 equation of motion to solve one particular question. Now if you look at this question, they gave us velocity, they gave us time, they say we should look for distance, they didn't give us acceleration. So we make use of these 2 parameters, velocity and time, to look for the acceleration first. Once we get acceleration, we can use the second equation to look for displacement. So, but before we start solving, remember, if you look at the velocity or the speed, look at the SI units, kilometer per hour. We cannot solve using kilometer per hour. If you look at time is in seconds. Therefore, this velocity need to be in meter per seconds. I don't know if you understand. We cannot solve with using this. If we solve, we will not get our answer. Now, how can you convert from kilometer per hour to meter per seconds? It's very easy. Now let me show you. Now since we have 90 kilometer per hour, to convert is very easy. Just put 90 here. Kilo means we want to convert to meter per seconds. Kilo means 1000, so multiply by 1000. Then all over. Remember, we still have meter here. We still have meter. K means 1000. Remember, we have meter here remaining. Now, 1 hour is the same thing as 3600 seconds. An hour means 3600 seconds. So if you cancel 0 here, we have 900 meter all over 36 seconds. So if you do the math, 900 going to 36. Now 900 going to 36 is 25 meter per seconds. So it's very easy to convert 90 kilometer per hour to meter per seconds. Is so easy. At first, kilo is 1000, so multiply 90 with 1000, we will be left with meter. Then an hour is the same thing as 3600 seconds. So when we multiply everything and divide everything, we'll be left with meter divided by seconds. So if we do everything, we'll get 25 meter per second. I hope this is clear. So this velocity now is 25 meter per seconds. The time is 10 seconds. We have to look for displacement. So we first need to use this velocity and this time to look for acceleration, which is very easy. So make use of this first formula first to look for acceleration. So V is 25, U is 0 plus A, then T is 10. So therefore 25 equals to 10A. Divide both sides by 10 to be 25 going to 10. A will be equals to 2.5 meter per second square. So our acceleration is 2.5 meter per second square. Now this acceleration that we get, we impute it to this second equation so that we can use it to look for the distance. So therefore S will be equals to our U is 0. You remember U is 0. So 0 times, remember U is 0. 0 times T, 0 times N to give 0. So we'll be left with S equals to half AT square. So we'll be left with S equals to half AT square. Now if we continue, S equals to half, then times 2.5 times the time is 10. 10 square is 100. So 2.5 times 100 is 250. Then 250 going to 2 will give us, 250 going to 2 will give us 125 meters. So this is the final answer. Now let me just summarize everything. They gave us speed, they gave us time, and they say we should look for displacement. So we cannot easily look for displacement without looking for acceleration first. We need to look for acceleration first. So we need to make use of velocity and time to look for the acceleration. We use the velocity and time to look for the acceleration. Remember, before we do that, we have to convert the kilometer per hour to meter per seconds. So our velocity was 25, our time was 10. So make use of this tool to look for the acceleration. When we get the acceleration, we imputed the acceleration to the second equation. We use it to get the distance. So the distance is 125 meters. So let's continue to the next question. I'll move to question 4. Question 4. If a car starts from rest and moves with a uniform acceleration of 10 meters per second square for 10 seconds, the distance it covers in the last 1 second of its motion is. Now, don't just go and solve orally. Just look at the question. The place I want you guys to take note of is the last 1 second. The last 1 second. So if you look at the question, they should calculate for the distance. They should calculate for distance. They gave us acceleration. They gave us acceleration to be 10 meters per second square. They gave us time to be 10 seconds. To be 10 seconds. They should look for the distance in the last 1 second. So you should look for a distance in the last 1 second. So this question is still so easy. Make use of the second equation. Make use of the second equation, which is an S equals to ut plus half a t squared. We are looking for the distance in the last 1 second. Now let me explain what they mean with the last 1 second. Now, if you look at the question, they said a car starts from rest. Remember, when you start from rest, u is always 0. So they said a car starts from rest and move with a uniform acceleration of 10 meters per second square for 10 seconds. So they say you should calculate the distance in the last 1 second. Now let's look at this is the first seconds, this is the second seconds, this is the third, fourth, fifth, sixth, seventh, eighth, 9, 10. Now the time is 10 seconds, abi? So they say you should calculate for the distance in the last 1 second. The last 1 second is the 10th seconds. The last 1 second is the 10th seconds, the last one. If they say the last 2 seconds to be the 9th one, the 9th. So they say you can look for the distance in the last 1 second, and the last 1 second is usually the 10th seconds. Let me understand. So let me tell you how to calculate this. At first, S equals to U is what? 0. So all here 0 times still give you 0. All here is 0. Then plus half times our acceleration is 10. Then times. Now whenever you see any question that they say calculate for the distance in the last 1 second, last 2 seconds, the third seconds, the fourth seconds, whenever you see any question like that, just do something. Do this. Do bracket open. T square minus T1 square minus T2 square, bracket close. T1 square minus T2 square. The T1 square, to solve this, the T1 square is the 10th seconds, while the T2 square is the 9th seconds. I know that you guys don't understand. For example, they say you should look for the 5th seconds. Like they say you can look for a distance in the 5th seconds. T1 will be 5, T2 will be 4. If they say you should look for, since they say the seconds is 10, and they say you should look for the last 10 seconds, without actually talking about, since they say you should look for the last 1 second, they're actually talking about the 10 seconds. So if you look for the 10 seconds, the T1 will be 10, then the T2 will be 9. If they say look for the third seconds, the T1 will be 3, the T2 will be what? 2. If they say look for the 5th seconds, the T1 will be 5, the T2 will be 4. I hope this is clear. Okay, if they say look for the 7th Let's just look for the 7 seconds. The T1 will be 7, the T2 will be 6. Let's look for the 8 seconds. The T1 will be 8, while the T2 will be what? 7. That's how they do it. In this question, the time was 10 seconds, and they should look for the last 1 second. They should look for the distance in the last 1 second. The last 1 second is what? This question is an indirect question. They want to trick you guys. This last 1 second is actually the 10th seconds. So you did the to calculate for the distance in the 10th seconds. It will be the T1 will be 10, the T2 will be what? 9. So I hope this is clear. So it will be S equals to half times 10 bracket open. T1 is, I said the T1 is what? 10. Since they should look for the last 1 seconds, that last 1 seconds is the 10th seconds. So the T1 will be 10 square minus the T2 will be 9. So minus 9 square. So now be S equals to half times 10 give you 5. Then bracket open. 10 square is 100. Then 9 square is 81. So 100 minus 81 will give us 100 minus 81 will give us 19. So 19 times 5. 19 times 5 will give us 95. So the answer is 95 meters. So whenever they ask you calculate for the distance in the 8 seconds, they are trying to tell you that the T1 is 8, then the T2 is 7. Whenever you see questions, whenever you see any question, they say calculate for the 8 seconds or the distance in the 8 seconds, the distance in the 4 seconds. You do the time like this. Do the time like this. T1 square minus T2 square, bracket open, bracket close. Okay, so we move to the next question. Question 5. A body start from rest. Whenever you hear start from rest, know that U is equals to 0. So a body start from rest and moves with a uniform acceleration of 6 meters per second square. Let's just look for the distance. They said this question is like the previous one. They said, what distance does it cover in the third seconds? So what distance does it cover in the third seconds? In the third seconds, remember the first seconds, the second seconds, and the third seconds. So if you can recall from our previous solving, I told you guys that we make use of that second formula, S equals to ut plus half at square. Ut plus half at square. So we have to look for the distance in the third seconds. So let's continue. S equals to U is 0. So 0 times T gives 0 plus half times the A is 6 10 times. I told you guys that whenever you come across questions that they say you should look for the distance in the 10 seconds, in the 8 seconds, in the 9 seconds, always make the time to be like this: T1 square minus T2 square, bracket close. So to be equals to half times 6 give you 3, then times bracket open. Now, since they say you look for a distance in the third seconds, our T1 will be what? 3, our T2 will be what? 2. If they say look for a distance in the 4th seconds, our T1 will be 4, our T2 will be 3. So it's very easy. T1 is 3, so 3 square minus T2 is 2 square. So it will be equals to 3 times bracket open, 9 minus 4, bracket close. So 9 minus 4 is 5, 5 times 3 is 15. So the distance is 15.